Hello guys, good morning. This is our last lecture for before the semifinals for MATH123A, Engineering Data Analysis. And today we will be talking about hypergeometric and also Poisson's probability distribution. Okay, so at the end of this session, these are the things that hopefully you are going to learn. Okay, so first one is to introduce to you guys the concept of hypergeometric distribution and Poisson distribution. And then next is to apply these concepts into practical examples by solving different problems. Okay? So basically, itong dalawang probability distribution na to is quite easy to understand once you fully grasp yung concept niya. Okay? So without further ado, we start now. Okay, we start with hypergeometric distribution. So hypergeometric distribution is a discrete probability distribution that describes the probability of k successes in n draws without replacement. Okay? So ibig sabihin, um, hindi siya katulad dun sa binomial experiment na um, independent yung outcome nung mga successive trials natin. So ibig sabihin, yung trial number 2 doesn't affect the result of uh, the result of trial 1 does not affect the result of the trial 2. Okay, sa hypergeometric ano siya, dependent siya. So without replacement. So ibig sabihin kung meron tayong sample space, meron tayong population, once na nag-take out na tayo ng portion sa kanya, sa halimbawa sa first probability natin, yung remaining, nag-take out tayo ng isang sample, yung remaining dun sa population natin, yun yung bagong ano natin, population natin na yung value niya is less than ng one sample taken from the first probability. Okay? So, hypergeometric distribution is also from a finite population size n that contains exactly k objects with a feature wherein each draw is either success or failure. So, the same as binomial experiment, two outcomes lang yung kinukuha natin, no? So, it's either success or failure. And then, the probability of obtaining X successes when sample size n is selected without replacement from n items of which k are labeled success and n minus k are labeled failure is given as this formula. So ito din yung formula ng hypergeometric distribution formula. Pero what I would consider for you to know regarding dito sa hypergeometric is yung concept na halimbawa meron tayong given population, tawag natin sa population natin na yan ay CN, okay? And then, may kinukuha sa atin, halimbawa may specific number of sample or uh, specific number of distribution na hinihingi, tatawagin natin X, no? Tapos dun sa population natin, meron tayong success, tapos meron tayong trial, dalawa lang yan. Okay? So, kung halimbawa tatawagin kong P, yung successes natin, ang matitira doon sa population natin is n minus p. Okay? So, kapag nag-select tayo ng sample ngayon, so let's say yung x, okay, yun na nga yun. So, halimbawa, yung sample x natin is a combination of success and failure outcomes. Okay? So, yung magiging formula natin is yung probability of yung x will occur is kunin natin yung success natin. Okay, so yung X successes natin dun sa given natin na P. And then, yung natitira natin, so since na-consider na natin si X, so matitira natin sa sample size natin is yung okay, so kukunin natin siya dun sa given sample size natin na n. So as mentioned dito, no? So yung number of successes natin, x successes, okay, taken from n items, okay? So yung k niya dito is p dito sa in-explain ko. So kung nakuha na si successes, yung multiply natin siya dun sa number of um, failures natin, which is n minus x. Tapos dito will be n minus p all over yung total sample, yung population natin taken nung sample space na required natin. So, n taken n. Okay? So, itong formula to is also the same as this one. So, ang ibig sabihin lang niyan is probability combination ng PCX multiplied by n minus P C n minus X all over n C n. Okay? So, mas madali lang siyang i-notate na ganito yung form niya. Okay? Pero yung calculation niya is applying combination pa din. Okay? And then we have yung mga formula natin for mean and variance of the hypergeometric distribution. So, as is na yan yung formula niya. Okay? So, let's start with example number 1. Suppose 5 cards are randomly drawn without replacement from 52 cards deck. Find the probability of obtaining 3 red and 2 black cards. Okay? So, yung gagawin nating solution is yung sa method na inintroduce ko, no? So, ano ang population natin? Ibig sabihin yung pinaka-total natin. Diba, 52 cards. So, ibig sabihin ito yon. 52 yung nasa labas natin. Tapos, ang idodraw natin dun sa, mula dun sa 52 ay 5 cards. So, ibig sabihin, ang n natin ay equal sa 5. Okay? Pero ano yung composition ng 5 na yon? So, meron tayong probability na 3 red and 2 black. So, ilan ba ang red sa 52 na cards? Diba? Meron tayong 26 na red, tas 26 na black. So, ibig sabihin, pwede tayong makakuha ng 26 na red, tapos 26 na black. Okay? So, kung 3 blacks and 2 black cards yung pinapahanap na probability, so 3 red and 2 black, no? Applying yung formula natin. So, yung sa red, since 26 yung total ng red, kukuha daw tayo ng 3. Tapos, yung matitira, yung failure natin, is mga itim na lang. Ilan ang kukunin natin sa itim? 2. Okay? Then, yung total ng ano natin, siya ay 52 taken 5. Okay? So, applying yung probability na formula, okay, or directly in your calculator, 26C3 multiplied by 26C2, okay, divided by 52C5. Okay? Your answer should be 0.3251 or 32.51%. Okay? So that is for example number 1. Okay, next, with the example number 2. Okay, 6 drones are drawn from a deck. Okay, so drawing ka lang ulit. May 52 cards ka, population mo, ang kukunin mong sample size ay 6. Okay? Tapos, ang pinapaunat, find the probability na una na 4 are aces. Okay? So, yung failure natin dito is considering kung ano yung number ng aces dun sa mismong deck ng cards natin. Okay? So, again, gagawa ka ng partition para dun sa left side, yung success, sa right side, yung failure natin. So, aces ang kailangan natin. Ilan ang aces sa deck ng card? Meron tayong 4 na ace, no? So, kung kinuha natin yung 4, mula dun sa total na 52, ilan yung matitira sa kanan? O ilang klase matitira? Meron tayong 48 na matitira dito. Okay? So, kung ang pinapahanap sa atin ay 6 cards, pero 4 doon ay ace, ibig sabihin may 2 na kukunin dun sa 48 pieces natin. Okay? So, yung probability na 4 are ace, no, will be Mula dun sa 4 na ace, kunin natin yung apat. Tapos yung failure natin o yung remaining natin na 48 cards, kukuha tayong dalawa. Okay? So, ito, over 6. Then, applying lang sa calculator natin. 4C4 multiplied by 48C2 divided by 52C6. Okay? So, we have 0.000005541 or 0.005541%. Okay? So, this is the answer for number 2. Okay? Next, we answer 2B. Kay 2B naman, 3 aces and 3 kings. Okay? So, ito yung diagram natin. Meron tayong 52 na cards. Okay? Ilan ang alas natin? So, ace natin, meron tayong apat. Then, kings natin, meron tayong apat. So, ilan na lang yung remaining natin? So, natitira na lang sa atin is 52 minus 8 is 44 cards, yung failures natin, o yung hindi natin masaselect. Okay? So, paano yung solution ngayon yan? So, 3 aces and 3 kings. So, ibig sabihin, 3 ace and 3 kings, no? So, ibig sabihin, mula dun sa apat na ace, kukuha tayo ng tatlo. Mula dun sa apat na king, kukuha tayo ng tatlo. Ano mangyayari dun sa remaining, sa failure natin? 44, kuha tayo ng 0. Okay? So, ito is 52, 6. Ito yung total natin. So, yung probability natin para makuha na 3 ace and 3 kings is 4C3 times 4C3 times 44C0. Okay? Over 52C6. So, yung probability natin upon calculation is equals to okay, 0.0000007859 or 0.00007859%. Okay? Again, yung success is pertaining dun sa required sa problem natin. So, ito yung success natin. Then, yung remaining na card, yun yung failures natin. Okay? So, pinaghiwalay ko lang yung ace and kings para malinaw sa inyo kung paano siya i-solve. Tapos, ito yung failures natin divided by yung total population taken 6 card. Okay? Next. A 2, 9, 10, Jack, Queen, and King are drawn in any order. Okay? So, in any order daw siya pwedeng ma-drawn. So, kung gagawin ulit natin yon, so we have 52 cards. Then, ito yung para sa 2, 9, 10, Jack, Queen, King. Okay? 2, 9, 10, Jack, Queen, King. So, yan mga yan, meron tayong tiga-apat, no? Na cards mula doon sa card natin. So, yan is 6 times 24. Ah, sorry, 4 times 6, 4 times 6 times 4, okay? So, meron tayong 24, plus 52 minus 24, 28 na lang yung natira dun sa cards natin. Okay? So, ngayon, kukuha daw tayo ng tigi-isang 2, 9, 10, Jack, Queen, and King. Yun yung success natin. Then, yung failure natin, matitira is 0 na lang, no? So, yung N natin is equals to 6. So, probability na siya ay 2 and 9 and 10. Okay? So, again, yung ano natin is end, no? And 9 and 10 and Jack and Queen and King. Okay? So, we have 4. Ito yung sa 2 muna, sa 2 na card. So, kukuha tayo ng isa mula dun sa apat. And then, dun sa 9, may apat din siyang card, no? Sa 10, sa Jack, sa Queen, sa King. Okay? Then, mula dun sa failure natin, natin tayong 28. Pero since 6 card na yung nakuha doon, 0 na to. Okay? All over, 52 over 6. So, yung probability natin yan is 4. 4C1. Pwede na natin yung erase sa 6, no? Kasi 6 times siyang i-multiply over 28C0. Okay? So, yung 28C0 pala is equal sa 1 lang din yan, no? So, over 52C6 pala. Okay? Yung result natin is 0.0002012 or 0.02012%. Okay? Last, we have three are any of one suit and three are of another. Okay? So, kada klase daw ng card, no? So, meron tayong 52. N natin is still 6 pa din. Then, ilan ang klase natin ng card? So, we have heart, we have diamond, then we have clover, no? Then, meron tayong spades, no? So, bawat isang yan, tigta 13 na klase, no? From alas hanggang king. Okay? So, ibig sabihin, yan yung component natin dito. So, meron tayong 13, 13, 13, 13 na heart, diamond, clover, and spade. Okay? Then yung remaining natin is wala na tayo dito kasi lahat na natin nagamit yung card. Okay? So, yung pag-solve dito, any one suit daw, tapos yung kasunod is any of the three. So, di ba kung halimbawa, mamimili ka dun sa apat na suit, so, ibig sabihin mula dun sa apat na suit, okay, yung probability natin will be 13. Kukuha tayo ng tatlo. Okay? Then, mula dun sa remaining, once na nagamit na natin yung isang klase ng suit, meron tayong tatlong remaining na klase. Tapos, mula dun sa mapipili natin, kukuha tayo ng isa, ng tatlo. Okay? So, 6 yan. Tapos, yung remaining naman natin is 0 na yung, so 0, C0 na din. So, equal sa 1 na yun. All over 52, 6. Okay? So, yung probability natin using that formula is 4 times 13C3 times 3 times 13C3 all over 52C6. Okay? Yung probability natin is 0.04821 or equivalent siya sa 4.821%. Okay? So that is our answer for letter D. Then last is yung letter E natin, at least one king is obtained. Okay? So at least one king. Okay, so 52 yung cards natin, N natin is 6. And then ang king natin meron tayong 4. Di ba? So remaining natin dito is 48. So kung at least one king, so anong ibig sabihin pag at least one king? So pwedeng maging 1K, no? Siyang maging 1K, 2K, 3K, 4K, no? Tapos ang gagawin mo pag multiplyin mo yung pag-a-addin mo yung probability niya, or pwede natin kunin na walang king tapos ima-minus natin dun sa magiging sa 1 kasi at least 1, no? So again, Kung halimbawa, consider natin kung at least one king, pwede tayong kumuha ng x is equals to 1. Okay? So, P natin dapat is x less than or equal to 1. Okay? So, ibig sabihin yan, P x so 1, P x equals to 2, P x equals to 3, tapos P x equals to 4. Okay? Pag isa-isahin mo yan, okay naman. Pero mas maganda gawin na lang natin, kunin natin yung x is equals to 0. Okay? Then, diba alam naman natin na yung total probability natin ay equal sa 1. Okay? So, ibig sabihin, yung probability na walang king na makukuha natin na value, minus natin yung sa 1 para makuha natin yung probability na meron siyang king. Okay? So, dito, mula dun sa king, wala tayong kukunin. Tapos mula dun sa remaining cards, kukuha tayo ng 6. Okay? Over 52/6. Yung probability natin ngayon na walang king is equals to 4 4C0 multiplied by 48C6 divided by 52C6. Okay? So, may nakuha tayong 0.6028. Okay? Then, yung probability natin na at least, no? So, pwede natin i-perform to. Again, pwede natin i-perform to. Pero mas madali ito na yung 1, yung total probability ng kahit anong pwede mangyari, minus natin dun sa wala tayong makukuhang king. Okay? So, ibig sabihin, considered na natin tong probability to. 1 minus 0.06028. So, equivalent ngayon yung probability natin in 0.3972 or 39.72%. Okay? So, ito na yung magiging final answer natin. Okay? 4 questions regarding dito sa sample 2 natin. You may message me sa messenger, no? Para ma-discuss ko. Next, sample 3. So, lots of 40 components. Each are deemed unacceptable if they contain 3 or more defectives. The procedure for sampling a lot is to select 5 components at random and to reject the lot if a defective is found. What is the probability that exactly one is defective? One defective is found and in the sample if there are 3 defectives in the entire lot. Okay? So, yung total population natin is 40. Then, yung defective, yun yung success rate na hinahanap natin. Okay? So, ibig sabihin yung success at failure na tinutukoy sa discrete probability is hindi lagi positive outcome siya, no? So, dito yung success na hinahanap natin is yung mga defective. So, ang defective mula dun sa 40, as mentioned, is 3, no? Is found in the sample if there are 3 defectives in the entire lot, no? So, ibig sabihin, mula doon sa 3, meron tayong remaining na hindi defective. So, yun yung failure natin. Okay? Ang pinapanap ngayon, exactly 1 is defective. So, ibig sabihin, yung probability natin, ilan ang isa-select natin sample? 5 components. So, n natin is equals to 5. Pero ang gusto natin, exactly 1 ay defective, no? So, ano yung probability na isa dun sa 5 pipiliin natin ay defective? Okay? Okay. Okay. Mula dun sa number ng defective natin, meron tayong 3, kukuha tayo ng isa doon kasi exactly 1. Then, since 5 yung kailangan natin kuning components, sabihin mula dun sa 37 na hindi defective, kukuha tayo ng 4. So, total 5 na yung sample natin over 45. Okay? So, apply lang natin, magiging 3C1 multiplied by 37C4 over 40C5. Okay? probability natin is 0.3011 or 30.11%. So, ibig sabihin, ito yung probability na kapag kumuha tayo ng 5 components, 30% chance doon is meron tayong isang defective doon. Okay? Itong example number 4 is just application ng formula for mean and variance. So, I will give you this as a practice. Kasi yung sagot niya, ang mu natin is 0.375. Then, yung variance natin is equals to 0.3113. Okay? So, verify nyo na lang using yung formula. Then, we now proceed dun sa natawag nating Poisson distribution. Okay? So, sa Poisson distribution naman daw, it counts the number of successes in a fixed interval of time or within a specified region. So, it is often used to model the number of occurrences of some phenomenon in a specified units of space or time. Okay. So, ano yung mga properties niya? First is the experiment consists of counting the number of times a certain event occurs during a given unit of time or space. Next, the number of successes that occurs in any interval is independent of those that occur in other non-overlapping intervals. Okay? Then last is the probability of success in an interval is proportional to the size of the interval. Okay? So, ibig sabihin lang nito, kay pag Poisson distribution yung pinag-uusapan natin, independent ulit tayo. So, ibig sabihin, yung trial o yung probability ng second trial will not be affected by the probability of the first trial. Okay? And then also, kapag Poisson distribution yung pinag-uusapan natin, ang lower boundary or lowest value ng x na pwede natin i-consider is 0, like katulad ng mga previous methods natin. And yung pinakamataas na pwede sa kanya is kahit anong value. So, pwedeng maging 1 million yung probability ng x. Okay? So, wala siyang upper bound limit. Ibig kong sabihin. Okay? Then, kapag gumagamit ng Poisson distribution, laging tatandaan na meron siyang tinatawag na occurrence per interval. Okay? So, occurrence per interval na yon, yun yung sa ibang textbook, ang notation niya is lambda. Okay? So, ito yung number of occurrence per interval. So, di ba sabi, may definite space and time na lagi na given kay Poisson distribution. Okay? So, ibig sabihin may number of occurrence per interval lagi siya na given, meaning yun yung lambda natin na dito sa given formula natin, equal siya dun sa mu natin or dun sa mean natin. Okay? Ibig sabihin pala ito is average number of occurrence per interval. Okay? Then si x natin is of course yung number of occurrence, no? Dun sa random variable natin. Okay? So, yung formula lang niya is madali, no? So, mu raised to x times e raised to negative mu over x factorial, wherein yung x natin, yung e natin is yung Euler's number natin na 2.718 na meron sa calcul na stored value. Then yung mu natin is yung mean natin. Or sa ibang textbook, it's lambda x e minus lambda over x factorial. So same lang yan. Okay? Then we try example number 1. Okay. So sa sample number 1, records show that the probability a tire will suffer a blowout in the next year. The probability given is 0.001. Okay? If the tires used is if 200 tires are used for a year, what is the probability of exactly 3 blowouts? Okay? So may number tayo ng tires na 200 tires. So pinapanap sa atin is probability na x is equals to 3. Okay? So, para ma-satisfy natin, pag in-apply natin yung formula, again, yung formula natin is this one. kailangan natin ng value ng mu o ng mean natin. And from previous discussion, yung sa binomial experiment natin, ang mu natin ay equal sa n times p. Okay? So dito, 200 tires multiplied by yung probability natin. So, ibig sabihin, ang mu natin is 0.2. Okay? Then yung x natin is equals to 3. So, substitute lang natin. So, 0.2 raised to 3 negative 0.2 all over 3 factorial. So, using your calculator na lang, yung calculated value natin will be 0.0011 or 0.11%. Okay? So, that is for example number 1. Next, example number 2. The average number of traffic accidents on a certain section of a highway is 2 per week. So, sabihin yung lambda natin o yung mu natin is average number of occurrence, 2, ibig sabihin 2 accidents per week. Okay? Find the probability of no accidents on this section during a 1 week period. So, yung x natin is 0. So, pinapahanap is p na x is equals to 0. So, equals lang yan sa formula again is yung formulang isa na binigay ko. So, same lang. Iba lang yung imbis na mu, lambda yung gamit. No? So, we have lambda raised to x, raised to negative lambda all over x factorial. So, we have 2 raised to 0 minus negative 2 all over 0 factorial. Okay? So, this is multiply, no? Sorry. So, we have 0.1353 or probability na no accident will happen is 13.53%. Okay? So, yan yung para sa letter A natin. Okay? Next question sa letter B. The probability of at most 3 accidents on this section of the highway during a 2-week period. Okay? So, same naman yung lambda natin na 2 accident per week. No? Pero dito yung probability natin ngayon is at most. So, x less than or equal to 3. So, ibig sabihin, kailangan natin yung probability ng 0 plus probability ng 1 plus probability ng 2 then probability ng 3. Okay? Then substitute lang natin sa equation natin. So, we have 2 raised to 0 negative 2 all over 0 factorial plus 2 raised to 1 negative 2 1 factorial plus 2 raised to 2 negative 2 all over 2 factorial plus 2 raised to 3 negative 2 all over 3 factorial. Okay? So, running that values in the calculator will yield to answer na 0.01832 or 1.83%. Okay? So, this will be our answer. Okay? Okay. So, sorry. This is not the total pala. Ito pa lang yung sa 1. Okay? Yung total will be 0.4335. Okay? Or 43.35%. Okay? Next, if there are 100 typo errors in 1,000 page, find the probability that a given page contains exactly 3 errors. Okay? So yung lambda natin is number of occurrence over interval. Okay? So ibig sabihin yung lambda natin can be 100 typo error all over 1,000 page. So ibig sabihin meron tayong average na 0.1 typo per page. Okay? Then pinapanak sa atin is exactly 3 errors. So using yung formula natin na lambda x e negative lambda over x factorial, we have 0.1 raised to 3, then e negative 0.1 all over 3 factorial. Calculating that in your calculator, we have 0.0001508 or 0.015%. Okay, so that is our probability. Okay, next, number 4, a telephone operator receives 3 calls per hour. So 3 calls per hour. Okay, find the probability that it will receive at most 3 calls. At most. So x less than equal to 3 ulit tayo. Okay? So, we have p ng x equals to 0 plus p x equals to 1 plus p x equals to 2 and p x equals to 3. Okay? Applying yung formula, so we have 3, 0, e negative 3 all over 0 factorial plus 3, 1, e negative 3 all over 1 factorial plus 3, 2 e negative 3 over 2 factorial plus 3, 3 e negative 3 all over 3 factorial. Okay? So performing that notation will yield to 0.6472 or 64.72%. Okay? Okay, next. Sa letter B natin is at least 4 calls. So, sabihin, since Poisson distribution tayo, again, yung number ng x is wala siyang upper limit. So, pwede siya maging 4, 5, 6, 7, 8, 9, 10. Kung ilan man. Kung mo, 1,000 calls. So, hindi natin alam. So, para malaman natin na yung probability niya na at least 4 and above yung calls na matatanggap natin, what we do is yung probability natin, no, will be equal sa yung unity natin na ibig sabihin yung 100% ng lahat ng probability minus natin yung probability na nakuha natin sa x less than equal to 3. Okay? So 1 minus 6472. So that will be 0.3528 or 35.28%. Okay? Next. So, 4 or more calls. So, ibig sabihin, halos same idea siya nung at least 4 calls, no? Kasi wala nga tayong upper limit. So, it can be more than 4 calls. So, yung probability natin for letter C na x is equals to 4 or more equals na siya doon sa calculated natin which is 0.3528 or 35.28%. Okay? So, same na lang siya. Okay? So, ito yung para sa Poisson distribution. So, if you have any more question regarding the two methods or the example that we have, please don't hesitate to contact me in the messenger so that I can address you. Okay? So, tomorrow, Tuesday, April 20, I'll try to be online from 9 to 12 during our time for Thursday, no? Pero bukas, Tuesday, I'll be online so that I can address question or um, any clarification that you may have. Okay? So this ends our lecture for today. Good luck in your examination, semifinals examination, and see you guys again next week.